Imagine standing before a structure so precisely built, so perfectly aligned, that modern engineers, with all their lasers and the computers, struggle to explain how it was made. This isn't a structure just of stone, but of a forgotten mathematical genius, one that seems to defy the very laws of physics and the geometry we hold sacred today. This is the reality when we gaze upon the wonders left by civilizations long gone. Our journey begins in the highlands of Peru, at the incredible complex of Sacsayhuamán. Built by the Inca Empire just outside Cusco, this fortress temple is a masterclass in megalithic construction. Forget neat, rectangular bricks. The walls here are made of colossal, multi-sided stones, some weigh over 120 tons, and they fit together so perfectly you can't even slip a credit card between them. These stones, man with 12 distinct angles, are etched in a complex, interlocking pattern that never repeats. This design gives the walls an amazing seismic stability, allowing them to withstand countless earthquakes that have crumbled later Spanish colonial buildings. The real mathematical mystery isn't just the sheer labor involved, but the geometry. The Inca didn't have iron tools, the wheel, or a written language as we know it. So how did they achieve such complex, curved shapes on massive stones that were hauled for miles from their quarry? Modern masonry requires precise templates and the measuring tools to get this kind of fit, even on small stones. For the Inca to do this on a colossal scale across thousands of square feet suggests they had a practical understanding of solid geometry and the art of cutting stone that was far ahead of anything known in Europe at the time. Their geometry wasn't on a flat page. It was practical, three-dimensional, and utterly flawless. It is almost as if they calculated the exact spatial coordinates of every single stone before it was even cut. Next, we travel across the Atlantic to Egypt, to the undisputed icon of ancient engineering, the Great Pyramid of Giza. We've all heard the debates about how they lifted the 2,3 million stone blocks. But the truly impossible parts lie in the mathematical and the astronomical alignments. Let's talk about precision. The base of the Great Pyramid is almost a perfect square. The difference between the longest and the shortest sides is a mere 4,4 inches over a distance of more than 755 feet. That's an angular error of less than 0.01%. To achieve this level of squareness on a massive foundation, built on shifting desert sand, without any modern surveying equipment, is an engineering feat that still astounds experts today. But it gets even more perplexing. The numbers P and the golden ratio, phi, seem to be encoded light into the pyramid's dimensions. If you take the perimeter of the pyramid's base and divided by twice its original height, you get ke 3,144. That is incredibly close to the value of P, which is ke 314,159. Now, the inclusion of this ratio is often debated, but its proximity is undeniable. On top of that, the ratio of the slant height to half the base length is 1,618, which is a perfect match for phi, the golden ratio. This special number is linked to ideal proportions and is found throughout nature in gross patterns. It's hard to believe this is all just a coincidence. Finally, let's journey to the enigmatic city of Teotihuacan in Mexico, and specifically, the Pyramid of the Sun. While its math might not be as obvious as the Great Pyramids, its entire layout follows a sophisticated system of measurement and orientation. The city's main street, the Avenue of the Dead, and all its major structures are precisely aligned 15,5 degrees east of true north. It's widely believed this alignment was designed to track the setting of the Pleiades star cluster, which points to a deep, practical knowledge of astronomy and the mechanics of the heavens. But the real mathematical oddity here lies in the unit of measurement they used. Archaeologist Hugh Harroston Jr. proposed that the builders used a standard length of about 32,6 inches or 83 centimeters. He called this the standard Teotihuacan unit. When you use this unit to measure the city, the dimensions of the pyramids and the plazas become clean, whole numbers. For instance, the perimeter of the Pyramid of the Sun is exactly 1,776 Teotihuacan units. This specific number appears consistently across the entire site. This suggests that the people of Teotihuacan, whose civilization mysteriously collapsed around 600 bukaan diaphragma, they had a highly standardized system of measurement across their empire. This was more than 1,000 years before the metric system was even invented. From the impossible polygonal fits of the Inca to the near-perfect P-based geometry of the Egyptians, and the standardized measurements of the Teotihuacanos, these ancient structures all tell the same story. The ancients were not primitive. They possessed a deep, intuitive, and the practical understanding of mathematics, geometry, and the astronomy that allowed them to go far beyond the limitations of their tools. Their impossible structures aren't a breakdown of mathematical laws, but a profound demonstration of a lost or forgotten set of rules that they had completely mastered. These mysteries lead to even more questions. For example, how did the Inca move their massive stones without the wheel? Let me know if you'd like to explore the theories behind that in a future video. Thanks for watching, and don't forget to like and subscribe for more journeys into our incredible past.